Alright, here we're looking at another exponential function. Now, let's start off with this. Suppose you invested $1,500 in an account paying 4.75% annual interest. Find the account balance after 25 interest with the interest compounded in the following ways. Now let's come up with our function here. 15 is going to be our A value. Okay, it's going to be a growth function. Again, we're hoping we have more money at the end than we started out with, and so that's why we put it in the bank. Now it's going to be 1 plus. Now, with this, what we'll do is go ahead and convert this to a decimal to use this. So let's move it over 2 places so we end up with 0.0475. Okay, and then time is going to be our exponent. Okay, so now if it's compounded annually, and this gives us our amount. Now, for the first time, I'm going to try to explain what happens to simple interest. What happens is you get more interest every year, and then when they add interest in, then you get interest on what we call interest. So our account balance was $1,500 at the beginning. So let's say what happens after 1 year. Okay, after 1 year, okay, they're going to give us some money for leaving our $1,500 in the bank. So we take the 1.0457 and take that to the first power and then multiply it times 1,500. Alright, so after the end of 1 year, we then have $1,571.25. Okay, well then what would happen is the next year, what we would do is they're going to take this amount and put interest with it. Now this is a way to do it without doing so much with the exponents, but I just want to show you what's happening to our money. So we then take the same, and the next year we take this amount and then multiply it times the 1.0475. Alright, so after the end of 2 years, we would have this amount. Okay, so what's happening is they're paying us interest on interest, because we get paid a little interest 1 year and then they put it into the account balance and then they pay interest on that. And so it's different than simple interest. For simple interest, we'd only be earning the 0.0475 times the 1,500. We only earn that on that amount. So it makes a difference over time. Let me show you that. If we had the 15 and we're getting simple interest, we'd multiply for 1 year, multiply it times that. Well, actually, we can put the 1 in front of it so I don't have to add. So it's times 1.0475. We end up with, after the first year, it's the same amount. But then the next year, so what's going to happen is the next year, this amount, the 71.25, they're going to add that into our account each year for 25 years. Okay, but for the second year, okay, we would end up with this amount in our account. Simple interest. Okay, so there's a difference. Now, it may not look like $3 and something, may not look like a big deal, but if you leave money in there for long periods of time, it's going to add up. So simple interest, you get the same interest year after year after year. With compound interest, you're earning interest on interest, so the amount of interest you're earning goes up. All right, but that's how what simple interest is. Now let's go to the problems that we're actually going to do with this. All right. Here we're looking at this particular problem. Now we're going to the different compounds. So what I'm going to do is we're going to figure out how to deal with compound interest based on the number of compounds. Now compounds means how often you're getting interest per year. So annually I'm getting interest once per year. Semi-annually I'm getting it twice a year. Quarterly I'm getting 4 times a year, and then monthly I'm getting 12. Now, what we have to do to come up with our rate, or how much money we're getting each compound, we have to divide this number by the number of compounds. But let's see how we would do that. So for the first one, it's going to be 1,500. Okay, that's our principal. 1 plus the 0.0475. Now we would technically we're dividing that by 1 because we're getting that once a year. Okay, so and our percentage rates in per year, and then time. Okay, however many years. So we would take t and divide it by 1 as well. I mean multiply it times 1 because we're getting 1 compound per year. So that's the 1 came from there. That's where the 1's coming from. All right, and so for this one, we just simply end up with f of x is equal to 1,500 times 1.0475 to the t power. Okay, and so after 25 years, we simply just plug in 25 for t, and then we can come up with our value. Okay, so after 25 years, okay, so I replace t with 25. So after 25 years, compounded once a year, okay, we would have $4,508.15. Now let's look at semi-annually. Now for semi-annually, we're getting 2 compounds a year, but we're not getting 4.75 each time. We're getting half of that each time. So what we would do is take the 1,500, and then we have 1 plus 0.0475. Again, it's compounded twice a year, so divide that by 2. And then we take our time, which is 25 times 2. Okay, so for this one. So I'm going to clean this up a little bit, and then we'll plug it in the calculator and see what we end up with. Okay, so what I simply did here was divided this, added it to 1. So that gives us basically how much interest they're giving us each compound. And then we'll get 50 compounds because it's 25 years where we're getting it twice a year. Okay, so we'll get 2 per year. Okay, now we can plug this in the calculator to come up with how much money we would now have. Alright, so after 25 years, compounded twice a year, we end up with $4,850.51. So that's a $300 difference, roughly, or a little bit more. Okay, so the number of compounds matters, how often it's compounded. Alright, now let's look at quarterly. Now, quarterly, okay, remember it's going to be 4 times. So what we would do is go f of x is equal to the 1,500 times 1. Now we're going to divide our interest by how many times they're going to give it to us. So they're going to give it 4 times a year, so we divide that number by 4. Okay, and then it's for 25 years, compounded 4 times. So that's where the 4 is coming, because it's quarterly. Okay, and then I'm going to clean this up. Alright, so once we manipulate, divide this, and add this, okay, we end up with this for our function. So now, if we plug it in, we end up with $4,884. Now, on all these, I'm rounding to 2 decimal places because we're talking about money. So we end up with $4,884.02. Okay, so hopefully you see that as the number of compounds per year increases, even though the interest rate per year is the same, okay, we're actually ending up with more money. Now let's see. Now the other common one would be monthly. Now monthly is going to be 12 times. So every month we get a little bit more interest. So we take the 1,500, which is what we put in the account. Then it's 1 plus our interest rate, which was 0.0475. Now they're dividing it up over each month, so we have 12. Okay, then it's the number of years, which is 25, times the number of compounds per year, which is 12. Okay, so for this one we end up with 1,500. I'm going to go ahead and clean it up, and then I'll start it because I don't want to run over on the video. Alright, so when we clean it up, we get this. and plug it in a calculator and see how much money we have. Alright, so at the end of 25 years, compounded monthly with an interest rate of 4.75, we would end up with $4,906.80. Okay, so as you notice, again, the number of compounds matter. And so if we compare this to compound, if we just get interest once a year, we would have this amount, $4,508. If we're getting interest every month, we'd have $4,906. So the number of compounds matters, and it increases. We'll continue this in the next video.